Hello everyone, this is another interesting map, geological map exercise 5th. Okay, so if we look at this map, in this map they are already mentioned that there is a fault. What kind of fault it is, we will find out that. And if something else is there in between this, we will find out those things also. And this type of questions, this type of map pattern, already asked in the gate exam. Gate as well as in GSA exam. Check out my other videos in which I have explained this type of question that came in UPSC mains exam as well as in gate exam. So now we have to find out the dip of the strata. So how we can know that we have to find the dip? Because these beds are not horizontal. How we can say that? Because no contour is parallel to the strata. So if we look at this part, here we're getting same contour cutting the same strata line. So this is our, and we have to draw, we have to find one more. This is, so we have to draw a parallel line. So this is 300, this is 200. So our beds are dipping from higher to lower. And if we want to calculate the dip, same scale. It is 2.5. 2.5 centimeter is equal to 500 meter. 1 centimeter is equal to 200 meter, and 1 millimeter is equal to 20 meter. So now we know that our beds are dipping like this way it is dipping. Like this. And we are not getting any opposite dip. You look at this 700, 600, same way it is dipping this way. All are dipping this way. So in which side our fault is dipping? Either fault is dipping in the same direction, in the direction of the dipping of the bed, or fault is dipping in the opposite direction. How we can find out that? If you look at this contour 400, same contour cutting the fault line, so we have to draw a parallel line for this also. And this is our 500 contour. This is our 500, this is our 400, so it means it is dipping this way. Fault plane is also dipping in the same direction. Now how we can tell that without going drawing the cross section? How we can tell that which side is going up and which side is going down? If we don't know this, in which side the fault is dipping, apart from that we can tell that. If we look at this boundary, and this boundary, so it is I will explain that part later. First I will wrap up the cross section and other things. So that it is going much easier for you to understand. Without drawing the cross section we are able to tell that. So I am drawing the cross section north-south direction. Okay, we can draw the cross section here like they mentioned. Okay, somewhere here. Okay, so that most of the repetition of it can also come. Okay, so this is our x, this is our y. Now if one more thing I want to tell you, that if this horizontal spacing is more, okay, this is a straight line. If the spacing is more, it means beds are gentle, or means low angle. If the spacing is less, it means steep. Okay, it tells us about the dip amount. Okay, so it means fault is high angle and these beds are low angle. Okay, and if we want to find out the true dip amount for this and this, how much distance it is, we have to draw, measure at 90 degree. Okay, it is 1.3. Okay, 1 centimeter is 200 and 3 means 6, so it is 260 meter, and this vertical distance 300 minus 200, it is 100. So this is cos alpha, so tan alpha is equal to 100 by 260 meter. So in this way we calculate the, okay, in the same way we can calculate for this also. The horizontal distance is 0.4 or 5. Okay, this is 100, 500 minus 400, so it is 100 and it is 0.5. Okay, so 0.5 means 100. Okay, in this way we can calculate tan alpha is equal to 100 by 100. 1 alpha tan inverse 1, if you know, you can answer. Okay, so this way we can calculate this and this. Okay, so now we have to draw the cross section along this xy line. Okay, you can use this scale, okay, for this. Okay, but I'm not using this scale. Okay, so these are our contours. So this is our 600 contour. Okay, maximum one is 800 and we know one is 300, 200. So I will start with 100, 200, 400, 500, 600, 700. Okay, so this is our 600 contour. Okay, this is our 700 contour. This is again our 700 contour, and this is our 600 contour. This is our 500 contour, 400, 300, 200. Okay, this is our 400, this is our 400 contour. Okay, this is 300. Okay, and this one is between 200 and 300. Okay, and this side it is between 600 and 500. So we'll we'll start with like this. So in this way we are joining roughly. Okay, okay, this is our fault. I will draw the dip mode. Okay, so I will draw. If we calculate from here now, dip amount of fault is more. Okay, with how we can understand, I already explained. If spacing between this is less, so it is higher angle, and if its spacing is more, it is less angle. Okay, I'm roughly going with. Okay, suppose this is our fault. Okay, and now I'm going to draw the beds. Okay, now here I'm getting this bed, then fault, and then this bed, then here I'm getting this bed. Okay, so now I have to draw the bed. Okay, it's the boundary now, low, okay. Now these lines are this is dotted one, this is our coal seam, this is again our coal seam, and we are getting same bed. Then this okay, and this, now we are getting of this, we are getting this sandstone, and this side we are getting this. So what kind of fault it is? This block is going this block is going this, so it is a reverse fault. Okay, so now from this is a cross section. Okay, in a similar way we can draw the index in the direction of the dip. Beds are younger, so it means 4 beds are younger in this side, so older beds are this. Over that we are getting this sandstone, coal seam, sorry, this coal seam, and then we are getting sandstone, and over that sandstone we are getting this is our index. Okay, scale we have to venture 1 millimeter is equal to 20 meter. Okay, and this side is our north, this side is our south. Geological cross section along XY line. This is our X, this is our Y. So in this way we are able to interpret that. Okay, now this is also a cross section. Okay, now I will remove this and I will try to explain from this map. Okay, how we can interpret. Okay, if we look at this part, okay, if this part is going this and this part is going this, okay, or you want to join this point, no, this side is going this way, because we are getting much thickness in comparison to this, exposure is much broader here na, as comparison to this. Okay, so it means it tells us that this part is getting uplifted. I don't know if I'm unable to find out this na, which side it is dipping. Okay, on the basis of that I am telling that. Okay, otherwise if it is a straight line, okay, if this fault is a straight line, so then I can only tell that this is up throw block, this is down throw block. Okay, I can only tell that. I'm unable to tell in that case. Okay, so this block is coming like exposed. If this is not fault, it is like this now. It's continuing like this. Okay, now this thing is getting broader. If it is something is getting broader, it means it is coming up. Okay, so this block is coming up, this block is going down. So this is a very interesting geological map. Hope you learned something from this map. Try to share this map with your friends so that they can also get the benefit. Thank you.